And the great thing is, that's the family right here. So this chart right here, the alkaline metals are always going to form +1s. The alkaline earth metals are always going to form +2s. So if you're like, gosh, what ion does it form? Because remember, everything on the periodic table is neutral but not stable. So it's going to form ions to become stable. That's the whole point of chemistry, is it's changing what it is to become like the noble gases, all right, to form ions. So it's always going to form a +1, +2. The transition metals are always going to form positives, but vary. Boron's family +3, carbon ±4, nitrogen's family -3, oxygen's family -2, halogens -1. So that's the ions they're going to form, okay? And the more you work with it, the more you'll see it and you'll get to know it. But it's not that hard. Don't freak out. It's not like it's like +5, -7, +9, and you have to, it's +1, +2, +3, ±4, -3, -2, -1. So it's kind of like going up the hill and down the hill, and +4, -4 is at the top, right? +1, +2, +3, ±4, -3, -2, -1. All of the positives are metals. Okay, so the metals will always form positive ions, and that's what a cation is. This word right here, cation, one of our vocab words, is a positive ion. Metals always form positive ions. An anion is a negative ion. Okay, so nonmetals are always going to form negative ions. And if you can't remember, oh my gosh, I can't remember. I know the staircase has something to do with it, but where are the nonmetals? Just think oxygen, right? Oxygen. You're not going to breathe a metal. You're breathing air, right? That is a nonmetal. So where is oxygen? It's on the right of the staircase. Everything to the right is nonmetals. Everything to the left is metals, okay? And just think gold and copper and all those are on the left side too, and those are definitely metals that you use all the time. So how do I remember that a cation is a positive ion? Well, look, cation, okay, that T looks like a plus sign. So there you go. And how to remember that an anion is a negative ion? We'll just look at it this way. A negative ion. Okay? So anion, A negative ion is an anion. All right? So any questions with ions, cations, or anions? Okay, like I said, what is the purpose of that? They're forming ions to become like noble gases, so that's how they're going to combine. And we're going to get to that when we make compounds. All right, the last thing is isotopes. Now, an isotope is an element that is the same element but has a different mass. So what would that look like? Well, if I have hydrogen, hydrogen has one proton. All right, there's a type of hydrogen that has no neutrons. So the total mass is what? 1, right? It has 1 proton and 0 neutrons. There's another type of hydrogen that has 1 proton, but it has 1 neutron. So what's the mass of that? 2, because 1 plus 1 is 2. And there's another hydrogen that has 1 proton, because all hydrogen have 1 proton, and it has 2 neutrons. And if that's the case, then the total mass is 3. So the mass number for this hydrogen is 1, the mass number for hydrogen here is 2, and the atomic mass for this hydrogen is 3. So that is where you get these decimal numbers on the periodic table, because if you look on the periodic table, you have a hydrogen, and it has a 1 here, and then it has 1.008 down there. Well, can I have 0.008 of a neutron? No. Okay, that's the average atomic mass. The average atomic mass. And what is that made up of? Well, that's the mass times the percent abundance of that element, or that isotope. So I'm going to show you how to do that real quick, because you're going to do a lab on that on Tuesday or Monday or whenever I see your period. So let's look at it this way. If I have hydrogen and I have 30% in nature is hydrogen that has 0 neutrons. Okay, so it's just H1 hydrogen. All right. 20% in nature is hydrogen that has 1 neutron. Right. So the mass is going to be 2. So it's 1 is the atomic number and 2 is the mass number. All right? And then 50% in nature, we're going to say is hydrogen with 2 neutrons, so it's going to be a hydrogen 3. All right? So how do I figure out the average atomic mass? You take the percent abundance and you change it to a decimal. Percent abundance, and you change it to a decimal. How do I do that? You move the percent over 2 spaces, right? So for the first one, 30% becomes 0.30. That's how I do that. You change the percent to a decimal, you just move it over 2 spots. 20% is going to be changed to 0.20, and 50% is going to be changed to 0.50. All right, so I change my percents to decimal. That's step 1. Step 2, you multiply it by the mass. So what is the mass of this hydrogen here?
1.
It's 1, right? Because there's 1 proton and 0 neutrons, right? It should be 1, 1. I don't know why. 1, 1. There. The mass is 1. 1 proton and 0 neutrons equals a mass of 1. So 0.3 times 1 is 0.3. All right, then take the percent, change to a decimal, times by the mass. All right, so then I take 0.2 times the mass, which is 2, so it's going to be 0.4, right? Or 0.40. And then I take percent abundance, change your decimal, times by the mass. Mass of this hydrogen is 3, so it's going to be 1.5, right? Yeah. Then I add those up. So add them all up, and you get 2.20 would be the atomic mass unit. That'd be the average atomic mass. Yeah. All right? So you take the percent abundance, you change it to a decimal, you multiply it by the mass, and then you add up all the time, add all of the different ones. All right, we're going to do one more example. Because like I said, you're going to need this for your lab on Monday. And I don't know if the sub's going to know what they're doing. So we'll say you have magnesium. All right? So magnesium, and we're going to say the first magnesium, all magnesiums have 12 protons. All right? The first one we're going to say has 12 neutrons, and so the mass is 24. And we're going to say that that is 70% in nature. And then the next magnesium is going to have a mass of 26. So we're going to say that is 23% in nature. And then the next magnesium is going to be 27. And we're going to say that is 7% in nature. All right? So what's my first step? Change percent to a decimal. Change percent to a decimal and change percent to a decimal. All right? Then you're going to multiply it times the mass. What is the mass? It's 24. This mass, 26. This mass, 27. All right, so what's 0.7 times 24? I don't have a calculator. So somebody knock that out with their phone or something. 0.7 times 24 is what? 16.8. Okay, what's 0.23 times 26? The what? 5.93?
8.
8.3 or 9.8?
9.8.
9.8. And then 0.07 times 27? 1.89. Now, I add up all these numbers. So that plus that plus that. And what do you get? Well, 17, we're going old school. 18 plus 8 is 26. That's 2, so then 8, 13, 14. So 24.67 AMU is the average atomic mass. Okay? So that's how you do it. And you'd be like, average? I thought average was add them all up and divide by 3. That is if they're all in equal abundance, right? So if they all existed equally, then you can add up the 3 masses and divide by 3. But they don't all exist equally in nature. This one's 70% nature, this one's 23%, and that's only 7%. Does that make sense? So these numbers, because you have these percent abundances, that accounts for what they exist in nature. So you just multiply by the mass, get a number, multiply by the mass, get a number, multiply by the mass, get a number, and add those numbers up, and that's your answer. All right, you're going to be doing a lab on that on Monday. All right, so that is average atomic mass, okay? And that's why there's decimal numbers on the periodic table. So when we look at something, if you see, sodium, and it says 11 and then 22.9898, okay? What are these numbers that I'm looking at? Well, this is the atomic number, and the atomic number stands for what? The number of protons, okay? And it also equals the number of electrons in a neutral atom, right? If it's a neutral atom. And then what is this? This is the average atomic mass. If it's a decimal point. If it's not a decimal point, you just call it the mass number. Okay? So that's it.